You might also get a question about memoization. And here, as you can see, we must design a memoization function which adds 10 to provided value and take it from cache if it was already calculated. And if you don't know what term memoization in JavaScript means, it means that we're caching values to avoid making the same operation again, which actually means, for example, we want to subtract two numbers, and if we did it previously and we already know the answer, then we must just return this answer and not calculate it again. Obviously, it doesn't make sense to make it with subtract or sum, but it makes a lot of sense when we have some difficult calculations. This is why here we must build an example of memoization function, and actually it's not that difficult. So here I want to create a function memoize add. And inside this function we don't need any arguments, but we want to create a cache inside. This is why here I will create cache property, and this is just an object. Now here I want to return a new function, and you can see that this is a closure, because actually we can store only some variables when we have a closure. This is why here I will return the function with value. And now here is how we are using it outside. So here we want to create new add function, and we just call here memoize add. So in this case, new add is a function and we can use it. This is why here we can write new add, for example 9, and this is our value. And in this case will be output 19 calculated. Why 19? Because actually, as you can see in our feature, it must add 10 to our provided value. So we're throwing inside 9 and we're getting back 19. But actually, when we're calling new add with 9 again, the output will be also 19, but it should be taken from cache. It should not be calculated again. And this is exactly what memoization is doing. So now we just need to implement this memoization logic. So here we can write if we have a value in cache, so we're checking if we have such value inside our object, then we want to just return it. And here I want to write console log so you can see that it is memoized. So here we'll be fetching from cache, and after this I want to write return cache, and here is our value. So as you can see, we don't do any calculations here, we simply return our value. And we also have else, and here we have calculations. So we're writing here calculating results, and after this we must really calculate it. So let's create here a value, for example result, and we want to put here value plus 10. And after this we must put it in cache before we return it. In this case we are storing our result for the next try. This is why here we can write cache value equals result. In this case we are assigning cache for our number 9. In this case, when we next time write here 9, then we are getting the value from cache. And after this we can simply return our result. And this is just the value that we calculated here. Let's check this out. I'm reloading the page. As you can see, we're getting calculating results. This is our first try here, and calculated 19, which actually means we really calculated something. But the second time this call, we have fetching from cache 19, which actually means we didn't calculate this time this number, but we took it from cache. And this is how you typically implement memoization. You can get different tasks, but the idea is the same. You have some cache, you have a closure, and you must deliver the value from the cache and put it in the cache on the first calculation.